Welcome back to Autoline Live from the Washington D.C. Auto Show, and joining me right now is Pat Davis, the Program Manager for Vehicle Technologies at the Department of Energy. Pat, thanks so much for being here.
Thanks for having me.
And Program Manager for Vehicle Technologies, that would imply anything and everything under the sun.
That's kind of true. We are primarily an R&D organization, but we perform R&D and try to solve problems related to improved energy, reducing our dependence on petroleum and improve fuel economy of vehicles, and that takes everything from lightweighting vehicles to improved combustion engines to batteries for electric drive to electric motors, you name it, pretty much if it's under the hood or in part of the car, we're interested in it.
So you're interested in everything, or is there anything that you particularly really bore in on?
You know, it's mainly about drive systems, things that improve fuel economy. So most of it's about drive systems, and you sort of stray away from that a little bit when it comes to lightweighting, which isn't really a drive system, but
But it affects them.
It affects the fuel efficiency of vehicles. So definitely have some interest there, and also do some work in fuels technology. Should also mention there's a piece of our program, about 10%, which is about deployment, getting technologies that are available today to be, adopted more than what they are.
Okay, for example, what?
Well, for example, flex fuel vehicles, natural gas vehicles in the medium duty sector. So, fleets, local municipalities who want to use, who operate trash trucks or other types of delivery vehicles that you might see being used by UPS or others. Could we do more efficient vehicles there? Could we do vehicles that are using an alternative fuel that displace petroleum? So those kind of things.
You mentioned flex fuel vehicles. A few years back, Detroit especially was really hot about these things, and then nothing seems to have happened because it's really hard to go find E85 anywhere.
Yeah, so
I shouldn't say anywhere, because in certain states there's plenty of it, but that tends to be very concentrated in the Midwest.
Right, so a lot has been happening on the vehicle side. Number one, a few years ago, the domestic automakers had pledged to have 50% of their fleet be flex fuel by 2012, and they're on track to do that. So it is sort of a bit of a chicken or the egg thing. Do you have E85 stations before you have vehicles? Can you have vehicles before you have the stations? So the good news is more and more of these vehicles are getting on the road. Today, probably only about 7 million, 8 million vehicles out there are flex fuel, but in the very near future, we're going to have tens of millions of vehicles. And at that point, you're going to start to see a lot more E85 stations available.
Oh, we will see more stations coming.
Absolutely, yeah.
What makes you so confident in saying that? Have the gas station people told you they're going to make that investment?
Well, there is some growth already. I mean, if you were to track, I don't have a graph with me, I wish I did.
Yeah.
But the growth of E85 has been steady. It'll continue to grow. I would concede your point, though, that we don't see any point in the very near future where it's going to be on every corner. First of all, we don't even have the ethanol production capacity in the U.S. To provide that fuel for everyone. Pretty much right now, most of the capacity is being used in E10 gasoline. So there's not really a huge push for that, but it'll happen. It'll come in time.
One of the problems with E85 is that it seems to me that the ethanol producers or the blenders certainly have priced it a little too high. I.e., as you know, with pure alcohol, you get about a 30% reduction in fuel economy. It's E85, so you get about a 25% reduction there. So some cars with NOx sensors, in my experience, don't see as much of a drop-off in it. But that tells me that unless the E85 fuel is at least 25% cheaper than gasoline, as a consumer, it doesn't make sense to buy it.
Yeah, and you see that fluctuate. I mean, just like any commodity, the price of E85, the price of gasoline, the price of diesel is going up and down, and they don't necessarily go up and down together.
No, they don't.
So there are times when gasoline's high and ethanol's a little low, and all of a sudden it looks really attractive, and then it can flip a little bit. So it's not consistent, and that is a problem. But the good thing about flex fuel is
doesn't matter. You go whichever way you want to, right?
Exactly.
Talk a little bit too about infrastructure for electric vehicles. That's got to be a hot button for you as well.
It is. Well, two major things happening with that. Under the Recovery Act, we have 23,000 charging points being installed that would support electric drive vehicles. So we're sort of just in the position where we're starting to install those now.
And these are publicly available places?
Many of them are home chargers, but thousands of them are public.
But you're talking, what, 220 volts in the case of the home?
There's three levels of charging. When I say 23,000 charging points, the vast majority of those are level 2. So level 1 is the plug that everybody has on the side of their wall. That's level 1, 110 volt, normally 15, 20 amps. Level 2 is the 220 volt, normally 30 amps. And level 3, sometimes called fast charging, is much higher voltage. It's
like 440, right?
It's 480, and the current they're still under some debate exactly what the current limits are.
So of these 23,000 points, most of them are level 1, or level 2?
Most are level 2. Of course, everybody has level 1.
Yeah, right.
Yeah, so we're doing that, and then I don't know if you listened to the State of the Union the other night, but President Obama talked about 1 million plug-in vehicles on the road by 2050.
Seems pretty ambitious to me. What's your reading?
Actually, not so. I mean, it is an ambitious goal from the standpoint, you don't want an easy goal. You want something that inspires,
you got to stretch, right?
Right.
The Sputnik moment kind of a thing, right?
Right. But, I personally have done, just a little bit of analysis looking at, if you look at all the vehicle announcements that have happened and you look at just media reports on what volume those vehicles are planning to be produced in, and you add them all up, you get very close to 1 million vehicles. And these are the ones that have been announced. There are many vehicles out there where we don't know what the production is going to be. Toyota announced their new plug-in hybrid. Ford announced the C-Max plug-in hybrid.
We just had Jonathan Browning from Volkswagen here saying, I think he said 2013 time frame.
That's right, and we don't even know what the production of those vehicles are going to be. But just adding up the projected production of vehicles like the Volt and the Leaf and the Ford Focus, you get very close to 1 million, even over 1 million. So we think it's doable.
We got some questions here from our chat room. Herman the German wants to know, will we ever import ethanol? Brazil's is close. There's an import tariff.
Yeah, right now there's actually
now
there's actually a tariff. So you're really asking me a question, will the tariff be lifted?
Yeah.
Because you can import it now. You just have to pay the tariff, which means it doesn't really happen.
Right.
So, honestly, I can't predict whether that tariff will be lifted.
But I think in just the opposite happening, Brazil has devoted more of their sugar cane production to making sugar. I had thought I had read someplace where they're actually importing some U.S. ethanol.
Yeah, we have been exporting some ethanol, but it's not a large amount.
Right.
I mean, let's face it, it's a fairly expensive proposition to be moving ethanol around by tanker. First of all, it's a very decentralized product from the standpoint of you're moving crops to a centralized point to make ethanol. You're having to move that to ports, load it on board tankers, ship it somewhere. It happens, but I don't really see that happening in large quantities.
Miradart says, other than warm, fuzzy feeling a guy gets from saving the environment, why would anyone fill up with E85? Has anyone here ever filled up with it? Well, I have, for one. I've test-driven flex fuel vehicles that have done that.
Of course, there are some who fill up with E85. Well, as I said, the pricing of E85 is variable, just like gasoline. So there have been times when it's advantageous to do so. There are times when it's not. So I would think most smart consumers are paying attention to that.
I know in certain states, Iowa comes to mind, you can get E85 for like a 30-35% price discount compared to gasoline. So you actually come out ahead buying it.
And part of that is a reflection of where ethanol is produced. It costs more to get ethanol to, say, Maryland than it does Iowa.
Okay, Michael Coates says, ask Pat Davis about the battery testing at Lawrence Berkeley Labs. Is that under your control? They do serious testing and they're not too high on current battery technology.
Is it under my control? It is sponsored.
You know what they're doing there?
It is sponsored by my office, yes.
Okay.
I would say this, look, we have a pretty big battery program It's not just Lawrence Berkeley. We support Argonne National Lab, we support Idaho National Lab, we support others doing battery work. And the battery work that we're doing is very promising. Number one, most people don't know that every battery on the road today in the hybrids that are on the road, including vehicles like the Toyota Prius, have battery technology in them that is under license from Department of Energy, as well as the...
I never knew that.
As well as the...
Including Toyota's...
Yeah, we developed that technology with a company called Ovonic. They, they license us. We have a partial ownership of that license.
You're talking nickel metal hydride batteries.
That's right,
now,
nickel metal hydride,
yeah.
developed by the Department of Energy. Now you see lithium ion entering the market. The Chevy Volt battery was developed in part by the Department of Energy. The batteries in the Mercedes S-Class hybrids developed with U.S. Department of Energy funding. So we've been developing batteries for a long time. We know a lot about batteries. There are shortcomings, there are things we need to solve, but the good news is battery technology is improving very quickly. A lot of people say, okay, vehicle electrification, what's the difference now than what it was in the 90s? Well, the difference is battery technology. When we started last round of electrification, I don't know if you remember, but the EV1 initially came out with a lead acid battery.
Right.
Then it went to the first generation of nickel metal hydride. And now we're on the lithium ion, and these batteries, are probably 3 times better from an energy density standpoint than where we were 20 years ago. So cost is going down.
But is it going, I've been using a figure that I read someplace that, we're looking for like a Nissan Leaf type vehicle, $15,000 for the battery pack. Yeah. Would that be about right?
Well, I don't want to say what Nissan...
Okay, yeah.
But I'll say this. Right now, we think lithium-ion batteries cost about $800 per kilowatt hour. So the Nissan has, I think, about a 22 kilowatt-hour battery. You can do the math. So, so it's expensive. The Chevy Volt has a 8 kilowatt-hour usable. We do our cost, by the way, in usable energy. Has an 8 kilowatt-hour usable battery. So, that would, tell you that's a $6,000 battery. That's a lot of money. However, good news is, and we're very, very confident about this, the costs are going down. We think by the middle of this decade, 2015, we'll be at $300 a kilowatt hour, less than half of the 800. And costs can still go a little bit lower than that. So the cost of batteries are going down pretty quickly.
So say that again, more than 50% by what time frame?
In 4 years, basically 2015, we'll be at about $300 per kilowatt hour. Right now, we're about $800 per kilowatt hour.
Mm-hmm. So we're making progress there.
Yeah, and it's not just volume. It's not just the fact that you're building more so the cost is going down. The batteries are getting better. And so it's not just about cost. The batteries in that time, they'll be less expensive. The reason they'll be less expensive is because they'll be better. They'll be smaller, more powerful, more in every way better. And that's going to be good not only from a cost perspective, but from a packaging perspective, from a weight to the vehicle. Some of these vehicles are quite heavy, these electric vehicles.
Yeah, they are. What do you make of the approach Tesla's taken of using these so-called laptop batteries, the 18650? What do you think of that approach going versus the prismatic, the more flat type batteries other purpose-built automakers are using?
Yeah, I think Tesla was trying to do a solution at the time that battery was designed. They had a brilliant solution from the standpoint of, they needed to leverage high volume manufacturing. They wanted a high energy battery. They wanted it to be already being produced in millions. Basically, they chose a laptop cell. Smart. The downside of that is you have a really tough problem in designing and building a pretty complex battery consisting of thousands of cells. So I think ultimately you'll see almost every automaker, including Tesla, will migrate away from that into fewer cells and decreasing the complexity of the battery. Any of the batteries coming out now, the Nissan Leaf, the Chevy Volt have larger cells, fewer of them.
I got a chance to test drive a Volt when it was freezing cold. In fact, below freezing in Michigan. It was 23 degrees, fully charged. I got up one morning, I had a 25-mile driving range, not the 40 miles I was expecting.
Sure.
And I knew cold weather would affect batteries. I had no idea it could knock 40% off the driving range. Anything that you guys are doing that could address the cold weather aspect of driving an EV?
Well, I would suggest to you that the 25-mile range in cold weather wasn't so much about the battery as it was you cranking the heat up. So
no, this is just getting in the car, not turning on anything except just firing the car up, not even turning on the electric seats or the heater, not even the radio. And so
I still challenge your experience from the standpoint of that battery is pretty well maintained temperature-wise. And when it's being charged, it's maintaining temperature. It really shouldn't see that kind of lowering of range just due to the temperature. It would, though, notice if you had the heat on and what temperature it was outside, and basically impact a little bit on the temperature side, and also a little bit on the fact that you have the heat on to give you reduced range. However, on the flip side of that, the range isn't exact. They estimate around 40. You can get up to 50. You can get down to 25.
Right.
There's a little bit of variability there.
Depends how you drive and all.
Depends on how you drive. But we think it's an excellent vehicle. Did you like the
No, I loved it.
performance?
Look, I'm a big EV enthusiast myself. Yeah. I love the Leaf. I love the Volt. But as I say, I don't let my enthusiasm for EV cloud my judgment as to how well I think they're going to sell.
Yeah.
And the reason I say that is because, as you know, hybrids are still less than 3% of the American market, even though there's all kinds of different hybrids you can go out and buy, and half that market is one car, the Toyota Prius. So when I see that, I go, man, I'm not sure these EVs are really going to catch on.
Well, we think, plug-ins are interesting from the standpoint of they solve the infrastructure problem.
What do you mean by that? Because you're plugging in, don't we need a better grid?
Well, people worry about, in a pure EV, you always have what's called range anxiety.
Right.
No matter how much range you have, someone's going to be worried that they need to go farther. And most EVs are coming in around 100-mile range.
Right.
And if you don't charge it every day, then you start wondering whether you can make it wherever it is you want to go. That's called range anxiety. But a plug-in kind of gets around that problem. It doesn't really matter, even though most people don't drive more than 40 miles a day. So a vehicle like the Volt is going to operate for most people on a daily basis, basically all the time on electricity. But for those trips that require 40 miles, and this is true whether you're going, trying to drive down to Richmond or whether you're driving to California from Washington, the Volt doesn't care. You're just going to keep on going. You'll switch over to a hybrid mode on gasoline, and charging infrastructure becomes not important, and range anxiety is non-existent at that point.
Charging infrastructure not as important because you've got that gas engine.
Because you can charge at home, and if you need to recharge, you don't really have to. You don't have to have some charging station somewhere and be planning on where you're going to go, because it'll switch over to a hybrid mode. But the good news there too, this is just from a government guy kind of perspective, if you get enough of those vehicles on the road, then there starts to become market pull for infrastructure. No one's building infrastructure at that point because they want you to use something. People are building infrastructure because there's a need for it. The customers are out there saying, we want it. And so, plug-ins can be a way, plug-in hybrids, I keep saying plug-ins, sorry about that.
Yeah.
Plug-in hybrids, and as the Chevy likes to call it, extended range electric vehicles, are a way to sort of get that volume of vehicles out there to have market pull for infrastructure, and can be a pathway to get us to the pure battery electric vehicle.
I'd seen a study going back a few years ago. I think it was from NREL, National Renewable Energy Lab. I think I got that right.
National Renewable Energy Lab, yeah.
That said, if the whole fleet in the U.S. was plug-ins, we could have massive impact on the use of oil in this country.
Sure, and there was that study. There was also a Pacific Northwest National Lab study that said that we have enough generating capacity today to power 70% of our existing vehicle fleet. Now there's 240 million vehicles on the road, so 70% of them could be electric, and you don't have to add generating capacity. That assumes a couple things, like people are going to charge at night, that you wouldn't have a problem if you had 5 of these vehicles on the same court or something, charging at the same time. But But still, overall, it's obvious you could have tens of millions of vehicles on the road and not impact our grid at all.
But I wonder about that when we already have brownouts in certain large metropolitan areas in the summertime. Everyone's running their air conditioning at night. What happens if you start plugging in all kinds of cars?
Well, if you look at the way we use electricity, there's really two peaks. One's in the morning when people get up, one's in the evening when they come home from work. So if you can avoid charging mainly in the evening, mainly it's going to be a problem when people come home from work, and let's say you get home you're lucky and you get home at 5 o'clock, you really don't want to be that guy plugging in right at 5 and charging the vehicle. This is why vehicles like the Volt have the opportunity to say when you need the vehicle to be charged. You can enter on a weekly basis, this is my standard time, I want a vehicle to be charged in the morning. And then it can decide when the best time for you to be using electricity is. That said, if you want it to be charged at 5, you can still plug it in.
Hopefully you don't shut the neighborhood down when you do that.
No, I think, ultimately, by the way, this is potentially a problem, but it'd be a good problem to have. If this is the only problem we have to solve, that's a good problem to have to solve. I mean, if we have so many of these vehicles on the road, think of the petroleum we're displacing if we have that many vehicles on the road that we're all worried about causing brownouts by the electric vehicles that are being charged. We can solve that problem. I would sort of contend that our dependence on petroleum is a larger problem and more important to solve than exactly when somebody plugs in that vehicle.
Is a smart grid coming anyway? Don't we need big infrastructure investments in the grid?
Well, the smart grid is coming. It's going to happen with or without.
And explain that. What does smart grid mean?
It means a lot. It depends on who you ask. There's a lot of different definitions.
Okay, what do you say it is?
Well, it's the ability of electricity users and appliances that use electricity to communicate with the grid and for decisions to be made. So, for example, there could be price points that are changing depending on the load that the grid is seeing. And an appliance could decide whether it's going to be drawing electricity at that point or wait until it knows electricity would be cheaper. It could be, and as I say, there's different definitions of smart grid, it could be the ability to throttle back on some of those usages when we're seeing some of those very peak periods. So it is a lot of things to a lot of people, but it's mainly about communication. It's mainly about knowing where the grid is and knowing what's drawing power.
What other technologies are you looking at? Because we've had on one of our shows before a guy come on with what they call the OPOC engine. It's this opposed piston engine thing. Fascinating concept.
Eco motors, right?
Eco motors, exactly right. Transonic combustion. It's talking about plasma injection.
Scuderia was right next.
Scuderia is right next to us and exhibiting.
Yep.
What do you think about some of these alternatives coming along?
Well, we are supporting about $50 million a year in combustion R&D. So we don't want to give. We talk about electrification a lot, but we don't want to give short shrift to combustion. Because if you think about the auto industry today, which is a very highly capitalized industry, there are hundreds of millions of dollars, billions of dollars out there sunk into the existing ability to build engines, for example. And so if you can come up with a better engine that significantly reduces fuel consumption, you can very easily and readily manufacture that energy with the existing that engine with the existing infrastructure we have. So there are real gains that can be had in improving the efficiency of engines. There's normally a cost associated with that, or we would have already done it.
Right.
There is some technology involved. So we are working on engine technology. Most of our combustion research is really focused on what we call low temperature combustion, where you can really see increases in engine efficiency 30, even 40%. So we're really talking about, for instance, with a gasoline-fueled engine, perhaps achieving efficiencies equal to or better than what a diesel can do. And if you could proliferate that technology and do it quickly, think of the energy that can be saved.
I've been arguing that we shouldn't just be looking at miles per gallon or kilowatt hours per 100 kilometers or however you want to measure it, that in fact we should be not even just looking at well to wheels and not just cradle to grave, but cradle to cradle, including all the energy that goes into manufacturing it in the first place, using it, and then recycling it. At the DOE, do you look at that sort of total life cycle analysis?
We do, but as you know, the devil's in the details when it comes to analysis. The devil's in the assumptions that you make. Mm-hmm. And so it is very difficult to do that kind of analysis and simultaneously keep track of every variable that you might have that goes into it. For the most part, most of our analysis is focused on well to wheels. We do some cradle to cradle type analysis like you point out. Most of it's well to wheels though. Mm-hmm.
Doesn't the well to wheels analysis though start to show that there are a whole lot of alternatives out there? Electric may not necessarily be the most efficient.
Well, there are alternatives. First of all, we think that you'll see those alternatives. I mean, you look at the response of the auto industry to the increased CAFE standards for 2016. Those standards are going to be met. They're going to be met with a number of different technologies. And if those standards, right now EPA and DOT are looking at CAFE standards that go beyond 2016. If they were to be increased even higher, you would even start to see a lot more technologies enter the market. And yes, it's not going to be one technology. You're going to see some electrification, mild hybrids, stop-start technology, even full hybrids, plug-in hybrids, EVs, but you're also going to see lightweighting. You're going to see higher efficiency combustion. You're going to see a lot of things introduced. Ultimately, though, if you look at pathways to really get to severe decreases in both petroleum consumption and greenhouse gas emissions, and what I mean by decreasing on the order of 80% or more, there really aren't very many pathways to do that. And if any of your listeners know of more pathways, we'd love to hear about them. But all the pathways we know about involve a combination of electric drive and low carbon fuels. So for instance, a plug-in hybrid that's running on both low carbon electricity and a biofuel, an EV running on a biofuel, a fuel cell vehicle running on renewable hydrogen. Those are the only pathways we know about. We'd like to hear more, though, if you got some brainstorms.
Okay, I was about to wrap it up, but we just got a question in here from the chat room. Charles Crome wants to know, what about CNG, compressed natural gas? Honda said it would sell it in all 50 states with its next generation.
Yeah, we like CNG, but we like it specifically and probably most favorably in the near term for these sort of medium-duty vehicles, fleet vehicles, because you can establish that centralized infrastructure. Other than that, there's nothing wrong with it. It's a mature technology, and certainly we don't have anything against CNG, but there is an infrastructure out there, and you'd have to establish it. And we do wonder, how many different infrastructures can we support?
Great point.
You're not going to have natural gas everywhere, gasoline everywhere, E85 everywhere, charging everywhere, hydrogen everywhere. Along the way, the market's going to make some choices.
Real good. Well, Pat Davis, thanks so much for coming in. Very interesting discussion.
Thank you.
This is terrific.
I
really enjoyed
this.
Yeah,
Thanks.
You bet.
AutoLine Live from the Washington, D.C. Auto Show is brought to you by our Inner Circle sponsor, Bosch, invented for life, and also by Dow Automotive Systems, innovations for clean powertrain solutions, and by the Steel Market Development Institute, automotive steel technologies powered by strength, fueled by innovation.